us to find dy dx for each of these equations, so we want to take the derivative with respect to x. So the derivative of y with respect to x. We can just write that. It's like we're taking dx of both sides. The derivative with dx of both sides. The derivative with respect to x of both sides. So even if it's a negative power, we still do the same thing. The negative 2 comes down and multiplies to 4. Negative 2 times 4 makes negative 8. And then just like before with the power rule, the power gets reduced by 1. So negative 2 minus 1 makes negative 3 up here. Okay? The negative 2 came down and multiplied to make negative 8. And then it got reduced by 1, so we went further back in the negatives. The 1 comes down and multiplies. Then it gets reduced by 1. So a power of 1 getting reduced by 1 brings us to x to the 0 power. In other words, just 1. So the derivative of 8x is 8. And the derivative of constant is nothing. That's it. We're done. You could rewrite it like this if you don't want negative exponents. But same thing, though. Okay. So over here, this is a function of x divided by another function of x. So that makes us think of the quotient rule. We want a derivative of this top function. So if you call the top function f of x, look, that's a 1/2 power. A square root is a 1/2 power. So you could rewrite this to the 1/2 power. So to take the derivative, it's the power rule again. The 1/2 power comes down, and then the power gets reduced by 1. So 1/2 subtracted by 1 makes negative 1/2. And then the derivative of minus 1 is just nothing. Okay. Same thing for the denominator here. If you call that g of x is the denominator, then the derivative of g of x, the 1/2 comes down and multiplies, and then it gets reduced by 1. So that's the derivative of the denominator. So now we have everything we need for the quotient rule. The quotient rule says it's a derivative of the top function times the bottom function kept the same, minus a derivative of the bottom function. Again, this is the quotient rule, right? Times the top function kept the same. This is all over the bottom function squared. Okay, so let's see if we can clean it up. That 1/2 x to the negative 1/2 power can multiply to everything. Look, this is x to the negative 1/2 times x to the positive 1/2. The powers add to make x to the 0. And when we distribute, the first term we get is 1/2 x to the 0 power. But x to the 0 is just 1, right? So we can just say the first term distributes to make 1/2. And then we got to distribute this over here. So that's going to be 1/2 x to the negative 1/2. And then over here, we're going to keep a minus sign. I'll protect the results in parentheses because we're distributing this. So 1/2 x to the negative 1/2 times x to the positive 1/2. The powers add to make x to the 0. Same thing. That makes 1/2. And then this distributes. So that's going to make minus 1/2 x to the negative 1/2. And I kept it in parentheses, right? Because the entire thing needs to be subtracted. Okay, so if you distribute the minus sign, you're going to have a 1/2 subtracted by 1/2. So those are going to cancel each other out. And then this is minus a negative 1/2. So 1/2 x to the negative 1/2 plus 1/2 x to the negative 1/2. That makes 1 whole x to the negative 1/2. That's what the numerator simplifies to be. Let me think. I think that's as far as we can go. That could be our answer, but if we don't want negative powers, you can kick that x to the negative 1/2 downstairs, like this, right? That makes it a positive. And if you're still looking for an answer, like in the back of the book or something, x to the 1/2 power, that means the square root of x. Looks like that's what the book has.